So, hello. We are not on time, so we are going to start now. The first oral communication panel. We are going to start with Jaime Madrigal González from iuFOR, University of Valladolid. So it's your time. If you want, you can take the other.
Okay, good morning, everyone. Thank you very much, the organization, for the acceptance of this presentation. I will talk about the functional significance of diversity in forests, but from a different proposal. Let me start with this picture. Is the classical representation of the opposing or seemingly opposing hypothesis to the diversity effects, which is the energy diversity theory in ecology, and more specifically is, if we take a look on the last two boxes, is the more individuals hypothesis that states that as long as we have more available energy, we are going to have greater or larger populations, and this because the size of populations is directly related with the extinction risks locally. Then, as long as we have larger populations, we are going to have more species. And so this hypothesis represents the way by which it's not necessarily more species determine more productivity, but the other way around. More productivity determine the possibility to have more species coexisting in the same place. I use this representation because, as you will see in the reference, this is a paper by Stork and colleagues in Ecology Letters, in which they say that this more individuals hypothesis is not really the opposing hypothesis, because both diversity effects and the energy diversity theory can be reconciled, and as they show in their paper, both hypotheses can be combined, and the combination of both hypotheses yield better results when we compare with real data. So we can have more species in places where we have more available energy, but also if we have more species, we can have a more efficient use of energy, and then we can have more individuals, and this can result in the coexistence and stabilization of the number of species. The question for me now is, okay, is there any determinant, environmental determinant, for understanding whether one of these hypotheses is prevalent over the other? Is there any environmental reason by which one of these hypotheses is more prevalent than the other? To test this or answer this question as possible, we created this methodological frame, which is based on structural equation modeling, in which we propose that we have in a given region in which we have forest data, we have a productivity proxy in the top of this scheme, and we have species richness in the middle, and we have abundance in the last box. And the intention here is to test the red arrows, which represent the differences, or the main difference between both hypotheses, the more individuals hypothesis and the diversity effects hypothesis. Okay, so as long as we put the direction, the causal direction, from abundance to richness, we are considering the more individuals hypothesis, whereas if we take the arrow from richness to abundance, we're considering diversity effects hypothesis. To test this, we gather forest data everywhere in natural forests in the world, in the different continents. As you will see, 24 data sets, and including here the color scale is an NPP, is net primary productivity, just to see that we are considering a latitudinal productivity gradient for this global scheme. And And here is more or less, in short, this is complex, but in short, this is the methodology we used to deal with this question. In the left, we have the arrow from richness to abundance. So this is the model in which we test the diversity effects hypothesis, assuming that more species is going to represent more individuals, more abundance. And the other way around is in the other side, in the right, in which the red arrow indicates or rises from abundance to richness. What we did was to fit both models separately in each of the 24 forest data sets. Okay, and what we did was to compute the Bayesian information criterion, which is it's an information-based criteria for model selection in structural equation modeling. Okay, so what we did was to create a delta Bayesian information criterion, in which we have first the BIC for the diversity effects hypothesis minus BIC for the more individuals hypothesis. So as you will see, if this a model is better supported when the information criteria is lower. Okay, so when we have a delta, a positive delta, is because the BIC for the more individuals hypothesis is lower than the diversity effects BIC. Okay, and the other way around, if we have a negative delta BIC, what we have is a BIC for the diversity effects hypothesis lower than the Bayesian or BIC for more individuals hypothesis. Okay, so positive values represent or support more individuals hypothesis. Positive values negative values represent support for diversity effects hypothesis. So what we did firstly was to compute all these models, to fit all these models, and to put this in a, let's say, global scenario in which we have in the x-axis latitude and in the y-axis this delta BIC. And as you will see, there is a pattern. It's a significant pattern. This is just correlation, in which we have close to the equator, we have prevalent negative values or more probability for negative values. And if we move northwards or southwards, we depart from the equator northwards or southwards, what we have is prevalent positive values. Okay, so this gives us just a preliminary result in which we can draw what happens, at least for this delta BIC and the support for one or the other hypothesis. Let me show this result. This is the main result of this research, in which we have pay attention, please, to the graph, to the scatter plot, in which we have the relationship between the MPP, the climatological MPP for this global latitudinal gradient, and the delta BIC. And as you will see, we have in the most productive places in the world, what we have is a prevalent diversity effects hypothesis, whereas if we move to the less productive forests on Earth, what we have is a more prevalent, more individuals hypothesis. Okay, what we did was to fit this structural equation model to test for potential artifacts in this relationship due to plot size or the number of species. As you will know, the number of species is different as we move from the equator to the poles, and so this could be an artifact affecting the results. We consider this to test whether this relationship we found can be a result of artifacts of plot size or species richness, and this, as you will see in the results, neither plot size nor species richness can explain this delta BAC. So, as a conclusion, for me, there is a question here in which considering diversity is fine, is very interesting to improve functioning in ecosystems, but sometimes we have to take a look on whether the ecosystems can support diversity and which species can be considered mostly when we are in stressed environments, in limiting conditions, in which not all the species can survive and all the species can coexist. Sorry, this is a complex research, but you can find more details in these references. Thank you very much.